Assalamualaikum. My name is Akila Farana binti Mazman. My matric number is P142410008. Now, I would like to introduce CNC machining. CNC stands for Computer Numerical Control. It is a manufacturing process that uses computer control machines to automate cutting and shaping operations with very high precision. The machine follows a program writing in G code, which provides step-by-step instructions for the machining process. CNC machining can process different types of materials, including metals, plastics, and wood. Because of its accuracy and efficiency, it is widely used in industries such as automotive, aerospace, electronics, medical, and general manufacturing. Some of the main advantages of CNC machining are its excellent precision and consistency, faster production speed, reduced material waste, and the ability to manufacture complex parts with high accuracy. These benefits make CNC machining one of the most important technologies in modern manufacturing. Next, let's look at the two main types of CNC machining used in this project, CNC turning and CNC milling. On the left is CNC turning. In this process, the workpiece rotates while the cutting tool remains stationary to remove material. CNC turning is mainly used to produce cylindrical components such as shaft, pins, bushings, threaded parts, and tapered components. It is more suitable for round or symmetrical parts and is highly efficient for high volume production. On the right is CNC milling. Unlike turning, the workpiece remains fixed while the cutting tool rotates and moves along multiple axes. CNC milling is capable of producing complex 3D shapes, pockets, slots, holes, and flat surface with very high precision. It is more flexible and suitable for manufacturing parts with complicated geometries using a wide range of materials. In summary, CNC turning is best for producing round components, while CNC milling is preferred for creating complex shapes and detailed features. Now, I will explain the methodology of our CNC machining project. The project started with the design phase. First, the raw aluminium material was cut to the required size. Then, we proposed and selected the wet stamp designed before creating the 3D CAD model of the part. After that, the G-code program was generated for the CNC machine, and the tool paths were verified to ensure the machining process would be accurate. Next was the execution phase. We first ran a simulation to detect and correct any errors in the G-code. Once the program was verified, the CNC machine cutting tools and workpiece were properly set up. Finally, the machining operation was carried out, followed by inspection and finishing to ensure the final product met the required quality and dimensional accuracy. This systematic workflow helps ensure that every stage, from design to the finished product, is completed with high precision and consistent quality.
My name is Nayli binti Nazihan. My matrix number is P142410265. On this slide, I will explain the cutting tools used in the CNC machining process. 3 cutting tools were selected, each with a specific function. First, the 4mm roughing tool removed most of the aluminium material to create the basing shape. Next, the 20mm left plunge cutter quickly removed material from deeper areas, helping reduce machining time. Finally, the 15mm finishing tool is used to achieve the final dimensions and a smooth surface finish. It operates at a higher spindle speed of 2500 rpm with a lower feed rate for better accuracy. Using the right tool for each stage improves machining efficiency, accuracy, and surface quality. Moving to the next one, this slide shows the 3D CAD model of the gear shift knob creating before machining. The part has an overall height of 65mm, a 32mm base diameter, and an M10 threaded hole at the base. It features a tapered shape with smooth curve, requiring both roughing and finishing operations to produce accurately. The part is made from aluminium with a machining tolerance of ±0.05 mm and a required surface finish of 1.6 micrometers. Creating the CAD model beforehand helps ensure accurate machining and a proper G-code generation.
Hi, Assalamualaikum. My name is Nur Arfa Alia binti Helmi. My metric number is B14241005. On this slide, I will explain the G code programming highlight. First, the program starts with the header section where G21 set the unit to millimeters, G40 cancel tools conversation, and G54 set the work coordinate system. Next, T0101 is used for the roughing tool, while T0202 is used for the finishing tools. Before each operation, G28 U0W0 return the machine to a safe position. For the machining parameters, roughing used as 1500 M03 with feed rate 0.15 mm reef. For efficient material removal, finishing used as 2500 M03 with a lower feed rate to achieve a smoother surface finish. Finally, G71 is used for the roughing cycle, G17 is used for the finishing cycle, and the program is verified through simulation before actual machining. Next, I will explain the material selection for this CNC machining project. Aluminium was selected as the primary material because it has excellent machinability, a high strength to weight ratio, and is suitable for precision turning operation. These properties make it an ideal choice for producing accurate and high quality machining parts. For the material preparation, the aluminium bar was first prepared with an initial length of 150 millimeters. Then the raw material was cut to the required size using a band saw to ensure accurate stock preparation. Finally, the edges were deepened and smoothed using a file to improve safety during handling and machining. This preparation process ensures the material is ready for the CNC ladle operation.
Hi, Assalamualaikum. My name is Nurul Aishah binti Sariza Zaidi. My metric number is B1424100037. Now I will explain the CNC machining operation result. Before we start the machining process, the G code was first loaded into the CNC controller and verified to make sure there were no programming errors. So this step is important because it helps prevent mistakes and protects both the machining and the workpiece. So the first machining process was the facing operation. Facing was done to create a flat and smooth front surface on the aluminium workpiece. This flat surface actually as a reference point for all the following machining operations. Next, the roughing process was carried out at a spinner speed of 1500 rpm. The purpose of roughing is to remove a large amount of excess material quickly and shape the workpiece close to its final form. After that, blanket cutting was performed to remove material efficiently from deeper areas of the workpiece. Finally, the finishing operation was completed at 2500 rpm. So this final step produced the required dimensions and gave the gear shift knob a smooth surface finish with a better accuracy. Overall, by following these machining steps in the correct sequence, we successfully produced the final gear shift knob with good dimensional accuracy and surface quality. Lastly, I will conclude our project. So this project helped us gain a better understanding of CNC-led programming and machining operations. Throughout the project, we learned how to prepare the material, create the CAD models, generate G code, run simulations, and perform the actual machining process. We also developed practical skills in selecting the correct feed rate, spindling speed, cutting tools, and machining sequence. These parameters are very important because they directly affect machining quality and efficiency. So one of the key lessons from this project that we get is that careful programming and proper preparation are essential for successful CNC machining. And understanding tool paths, and machining parameters help ensure accurate dimensions and a good surface finish. In conclusion, the knowledge and experience gained from this project will be very useful for future manufacturing and engineering applications. Thank you for listening. Bye.